Hello, Temporal fans. This is going to be a slightly different video from the rest of the videos on our YouTube channel, and it's something that we're trying out. A lot of the work that we do is open source, but we never really work in public to the extent that we share with you what it's like to work at Temporal and what it's like to work on a product feature. So I started to think a little bit about maybe sharing a bit of that process. And it's very hard because there's a large code base, there's a lot of features, a lot of things to take care of. So it's better to find an isolated feature that is maybe understandable from end to end. And if you're interested in collaborating with Temporal as an open source contributor, or you're interested in working with us in the future, maybe this video will be helpful in giving you an idea of what it's like to work with us, particularly with the Rust core. So we have a few teams. We have the server team, we have the cloud team, we have the SDK team, and more teams on the way. But this video probably will be most useful for people interested in Temporal SDKs, and particularly our Rust core SDK. So about a year ago, we published some reasoning on why we picked Rust and what we're doing with Rust. So definitely check out this blog post. I'm going to assume that you can look it up yourself. But the bulk of the work is on GitHub, and this is sort of the Rust core SDK. And I think there's not really much in terms of orientation apart from the architecture document. And so I think this is definitely worth a read. But what we ended up deciding to do was to work on a single contribution and maybe show some of the results. And me being the dumb person who's never actually seen the code base at all, me trying to just talk to the people involved to see if we can do that. So this PR was implemented in two phases. One with me just making my first attempt with the help of Spencer, who gave a little bit of guidance. And I got to a certain extent, but I couldn't make the test pass. And so then it was handed over to Matt to finish the rest. And so you can see in the video that's about to be shown to you, the three stages in which we had the discussions and onboarding to the SDK core code base. It's obviously not the full code base, and nothing is, but at least it'll help you navigate a little bit insofar as this current repo structure stays stable. But probably, I think more useful to you is it gives you a sense of what it's like to work with us and maybe collaborate on a feature. So enjoy, and I'll see you on the other side.
Okay, where do I go?
Yeah, let me, I'll just share my screen. Or do you want to share your screen? I'll tell you where to go.
Yeah, I can share my screen. So what we're trying to do. Okay, let me recap what I think we're doing, and then you can correct me if I'm wrong.
Okay.
As far as I'm aware, we have the TypeScript SDK. We have a search capability, which is kind of half implemented. We have declaration and workflow creation, and then we are trying to implement upserting search attributes.
Yeah.
We may need to implement a bunch of these other features as well.
Yeah, we're not even going to touch TypeScript yet, but that's what it's going to be for. Yes.
Okay. All right. So so there are two layers that we're probably going to touch SDK core.
Yeah. And in fact, that's all I was thinking of doing. But after this, it would then be adding the actual TypeScript API, which uses what we're going to do.
Okay. And then as far as I know, there's somewhere in here that has all the finite state machines. Is this it?
Mm-hmm. Yeah, it's in source/machines. You should just get it. I don't know if you want to spend time doing this right now or if you want to just look at it on GitHub, but you should, clone it and get like CLion or whatever. But we could just look at it on GitHub for now too, if you want.
All right. Yeah, let's try to stay high level on GitHub, and then I can.
Okay. Yeah. So go to machines there.
Yep.
So and then there's an upsert search attributes one. And this
already exists.
Yeah, all these skeletons I code gen from the Java code actually. But so this part is going to be like very trivial.
Okay.
The slightly more interesting part is going to be like all the places that this will now have to get added to become usable. But in the meantime, let's look at another like simple state machine. So if you go back up one level, we can look at one that actually is implemented. Let me think about what a good one to look at would be. Probably just timer. Timer is like fairly straightforward. Okay. So if you look at timer, there's a handful of things in here that you won't care about, like cancel doesn't matter. Nothing that has anything to do with cancel is going to matter. Go down to the FSM part, this macro. So this whole thing inside this FSM exclamation mark, this is a macro. So like this is some like, little custom DSL basically that I made, right? And it actually results.
Where's it defined?
There's a at the very top level of the repo, what the thing you first thought might be it, FSM, that defines this whole. But you shouldn't really need to know too much about how that works, especially if you're just looking at the other state machines as examples. It's pretty straightforward. But basically, the idea is like little structs get created for all these different states, and all of these little transition arrow things, you like have to implement the function for them if one is specified. So like the first part is like this event name, so like schedule is an event name, and then OnSchedule is like the event handler for that event, and all that stuff gets created. So if we're looking at this one, you get the other one, the Upsert Search Machine one up too, and we can look at them side by side.
Does it check for completeness, or does it check for like hanging states? Do you know what I mean? Like,
kinda. I mean, so like it knows what states are final, but it's expected that they're going to be final states, right? That's like, that's something that makes sense. So as you can see, this one has less going on than timer does. So really kind of all this one's going to do is, if you look at the schedule, let's look at the OnSchedule part of timer. So if we go to this one and we just kind of like scroll down a little bit, there will be someplace new timer. Yeah, here we go. New schedule. This is the part we actually really care about, which gets called by new timer. So new schedule down here below it, you'll see what we kind of do here is we self new is just like instantiating the state machine, and then we immediately make a schedule event happen. That part's actually kind of dumb. I might go back and actually refactor almost all these state machines do the same thing. They make a state machine and then they immediately run the schedule event, and it's kind of pointless. We should just create them in the state that happens after schedule, because like, why bother? But anyways,
it's like two lines of code.
Yeah. So like they all basically do that same thing. And what you'll find is that this little let command equals command doodad. So we kind of, what we're saying here is we return two things, the tuple at the bottom. We return the state machine and that command thing. So the new scheduled, and what you'll see in new timer back up above it is we end up returning this new machine with command struct, and this ends up getting used higher up, and we'll talk about that later. But like we end up returning the machine, and we return a command that like we want to send to the server. And so like this is like a temporal command, right? So in the case of the timer, it's start timer, right? In the case of what you're going to do, it's going to be upsert search attributes. And that's already 50% of what needs to happen. Then the other 50% is just the on upsert search workflow, or blah, blah, blah. Sorry, go back to the other one. The on upsert workflow search attributes event handler. That's like the only other thing. And that's just making sure like on replay that you see the command. And that's the other 50%, and that's it basically. Is that
on replay you see the command?
So like in the event history, right? You're gonna have upserted search attributes or whatever it's called. And that's just when we're, processing event history and we see that, we make sure it matches up with the fact that you wanted to do this for determinism reasons, right? So like if it was missing, we would blow up because we'd be like, oh, your workflow said you were going to upsert search attributes, but that's not in the right place. Or if it was there and you didn't have the code, right? Same deal. We'd get some mismatch. Some other state machine would try to process the event and we'd blow up. Does that make sense?
I think I don't know the consequences if I did it some other way. Like it seems like we'd have to create pairs of commands at all times, because we always have to replay everything, right?
Yeah, kind of, more or less, right? Like what happens is just like the machines get put in a queue basically, and we always expect to see the corresponding events happen at the right time for whatever is at like the front of the queue.
Okay.
And that's true of all of them, right? More or less, with some weird stuff accepted, like weird local activity stuff and things like that. But yeah, so, the short description of all this one does is create a command and then also make sure that it saw that command recorded in history. That's like literally all this one is doing. It's super simple. Okay. Some of the other ones, right, they have different, like for activity, for example, it's got to handle like when it sees the result event and things like that. So there's more stuff going on. But like all this one is doing is just issuing the command, saying that the command was issued. That's it. So that more or less covers what's going to happen in this file. And I think I'll kind of leave it as an exercise to you to kind of look at the other ones and figure out how to implement that, because it should be pretty.
You literally, I was expecting to have to implement this as well, but it looks like you stubbed it out already. So all I have to do is this. And it's like 6 lines of code. So.
Yeah. Yeah. I mean, you have to write some tests too, but it's that part's pretty easy.
Okay.
So let's talk about how they actually get used. So if you go back up to source, and then I've been meaning to do a little reorganization here because kind of really some of these belong in the same directory, but go to workflow now. And I think we want to go to workflow tasks. I tend to just search for stuff, so I forget exactly where everything is, but
I can search.
Yeah, let me just do it in my ID real quick because it'll be easier. Okay. Okay, yes, you actually want to go to source machines, workflow machines. That's what you're looking for. So it actually was in the same directory. Not workflow machines, the directory, but there's workflow machines, the file, which is also in there. There we go.
That's not confusing.
So there's a couple. Most of what you'll have to do should kind of end up, I think, all in here. There might be a handful of other places, but like we saw a new timer in the timer machine, which was like that top level function. Yeah, just search for a new timer in this file. Yeah, go to where it gets used somewhere. Here we go. So there's this function here that stuff has happened higher up, but basically what this function is getting is like a list of things that the language side wanted to do. So like it might see, for example, in their workflow command, add timer, right? And if we saw that from Lang, well, okay, we know we need to like make one of these timer state machines, which is why we call new timer here. And then we do some other stuff. This like add command to workflow task function means, okay, like we know we're going to put this command in the current workflow task when we end up finishing it. And like, we get the machine out of there and we have to create like a little ID for it. And what you're going to need to do for the Upsert search, oh gosh, such a mouthful, for this thing is basically exactly the same as what it looks like here in new timer, right? We're going to make a new Upsert search, blah, 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 state machine, and we're going to put it in the current workflow task. It's going to get some ID and like Bob's your uncle. That's basically it.
What is this get some ID? Is this like just a random UUID or something like that?
No, it's not random at all. It could never be random, right?
Sorry. When I don't mean random, like, yeah.
Yeah, it's an
identifier.
It's an identifier. It actually comes from Lang, right? So you can see inside of the add timer thing that came from Lang, there's these attributes and we get the sequence out of it. So let sequence equals attributes.sequence, right? So like language side told us what it wanted to identify this timer with, and we're just writing that down so that when eventually it fires in the example of a timer, we can go back to Lang and we can say this timer that you told me was called, 1 is now unblocked.
Got it.
Yeah. And so but that doesn't even happen with Upserts because we never return anything to Lang. It's like a fire and forget thing, right? Like there's nothing to unblock. So I don't know that it's even going to have an ID. It's like not really relevant. It probably has one just so that we can, do the replay check that I was talking about, but the ID is kind of like irrelevant. All we have to do is just make it up deterministically.
Okay.
And that's like, mostly it. There's going to be like a couple of other like protobuf conversion-y things. Like there will probably be a part where you have to construct the actual like protobuf command that we send to the server like the right way.
Where does that happen?
So there's, yeah, not in here because these are the actual protobuf definitions. Get the SDK core protos, that one in the middle there. Yeah. So like this is a separate crate. And if there should just be one file in source if you go in there. And there's just like, this is a super long file that just has lots of like really boilerplatey crap around creating different kinds of protobufs. So like somewhere, you know, auto-generated in here is an upsert search attributes like command. So like there's like an event type, for example, and
It's the only instance here actually.
Yeah. So like what you're going to need to add, go look for like a timer, not timer started, but like look for, you know how we, in the last file, we had a workflow command add timer or whatever. Is that what it was called? Yeah. Look for add timer in the protobuf file. And never mind. It won't be in there. But that's fine. That reminds me, like you're going to have to add a new workflow command variant. So if we go back to the workflow machines thing, which
okay.
Yeah, is super easy.
Right here.
Yeah, in that file. So like if you look at where workflow command is defined, which I think is in this file, might be in a different one. Oh no, it's actually in the machines top module. So mod.rs there, right in the middle.
There we go. Yep.
Yeah. So now look for WF command. Yeah, here we go.
Oh, that's easy.
Yeah, so this is like very boring, right? These literally these just wrap the protobuf types that Lang talks with core in terms of.
I remember this is the thing that you wanted to use macros for, right?
Yeah, this would be easy to macroify. It's kind of stupid actually in some ways, like because the only thing that needs to be different here from something that exists in the proto file is that no commands from Lang variant. Because sometimes it just doesn't respond with anything. It's like if Lang was like, I don't have any new work to do, right? Like you unblock some stuff, but I still am waiting on things.
What's behind the naming choices? How come some of these are different names?
You know, a lot of it was just to make some of them shorter. Some of them are very unnecessarily verbose.
Okay. Yeah, just randomly adding execution behind everything.
Yeah, exactly. But so that's there will be that'll be something you need to change in one of the proto files. So if we go to the directory that you first wanted to go into that was called protos, not SDK core protos, that's at the top level. Yeah, this guy. So go to local workflow commands. Yeah, so here we can see you're gonna add one here. In fact, it's commented out at the bottom. It's the last one. So that'll need to be added. And that message needs to be defined. And I think all it needs to have in it is like probably like a key value mapping. You might want to refer to like and I actually forgot to mention this, like when you're implementing the state machine part itself, usually since I code gen them from the Java ones, you can refer to like how Java defines a state machine to get an idea of, you know, what actually needs to happen. So maybe let's take a look at that real quick too, if we go to the Java SDK.
I don't have it in my auto memory. Yeah, where do I go?
Okay, yeah, so oh well, Dimitri restructured this a little bit. Go to Temporal SDK. source, just typical Java nonsense with like 9 directories. Yeah, workflow. I think,
Internal?
actually, no, yeah, internal. It should be internal. State machines. There we go. Yeah, and there should be an upsert, blah 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 one. There we go.
What's a pummel?
It's I don't know why those are checked in, but it's the diagram of them. And so this, like, you know, it is the same thing that we just looked at. And if you scroll down a little bit, there should be like what happens in the handler. Yeah, here we go. Command new builder. It's making an upsert search workflow attributes command, and it's setting the search attributes to be search attributes, which isn't particularly revealing. But like that thing there, you know, is probably telling you what needs to be in that protobuf file that we were just looking at. So like whatever that type of that search attributes variable is, I'm not sure what it is. Probably is defined. Yeah, search attributes, unsurprisingly. So, so that's literally just the command that gets sent to server. So we can see the import for it up there. So like that's literally just like the protobuf command. So like if we were to look at the Temporal API repo, you know, which you can actually see from inside of the core repo too, since it's like inlined in there.
Is it inlined?
Yeah, it is. In the same place we were looking at the protobuf that we were just talking about a second ago. Yeah, so there's that one, API upstream.
Why is it inlined?
Because it's just way easier. It's like it uses a subtree instead of a submodule, which is just a lot easier to work with.
I've heard. I got screwed up with some submodules once, and I never want to do that again.
Yeah, so go to command. These are all defined in there, and we'll find it'll be in here. Oh, there we go. Of course, it's a separate message that's defined somewhere else in common. So it's just a wrapper around.
Okay.
See that comments? Yeah, that thing. So we want to see what that is.
Here. Why is that?
Oh, no, it wasn't called that. It was just called search attributes.
Right.
Oh, yeah. Okay. So I was right. I was right. It is just a map of,
string to payload.
Yeah, exactly. So that's all that the message that we were just looking at that doesn't exist yet in the local proto, it'll look exactly like this.
Okay.
Yeah. And that's what Lang will send to us when it calls the API. And then you're basically just going to pass it straight through to server. Like you don't even need to look at it, right? Because there's nothing you can do.
It's just a simple map. Yeah.
Yeah, exactly. And that's like pretty much it. I mean, there's like, you know, there's like some details here and there, but I think it's probably more useful for you to just like try and play around with it and see what you get confused by and ask me questions, and I'll be happy to let you know.
Yeah, I bet I'm gonna come up with a bunch of questions as well.
Yeah, sure.
But
yeah,
this is a really good exercise for orienting myself to the code base, and also understanding how many layers we have going on, which is something I've always been curious about.
Yeah, there's like, it's definitely not the easiest thing in the world to follow. Like, I think there are some things we could do that would maybe get rid of like kind of how meandering some of it can be, but at the same time, like, you know, I don't know how worth it that is, right? Like, stuff is working just fine. Like, you know,
if it ain't broke, don't fix
yeah,
it.
exactly. Cool.
No, I would love, you know, for us to be truly open source, we need to write a contribution guide, right? So something like this, something like me going through this, and feeling the pain, would help eventually, but that's a long way away.
For sure.
Can you give me one indication about tests? I do tend to learn a lot from tests.
Oh yeah, that's a good point. I actually was going to mention that explicitly too. So the other thing that's kind of like bonus points, that's some of them. Those are the integration tests. There's also unit tests that are inline in like a bunch of the files. There's one of the things that I do want to clean up is just like a bunch of different ways of writing tests, which I don't love. The only way though that you should probably write them, which is and yours is easy to test, is there are let me just like get you the link to it real quick. So
I just realized you have an Arch docs. Nice. Oh, just for sticky cues. Okay.
I'm trying to think of one that is not super complicated, but uses the newer form of testing. Because I think, like, for example, all the timer ones use kind of the older style of testing that I want to get rid of. Oh, no, it doesn't. Okay, this one works. Yeah, so if you go to the timer state machine and just go like all the way to the bottom.
Sorry, are we're talking here?
Yeah, I think you still have it open somewhere, the timer state machine.
I've opened so many now that like oh yeah,
there we go. Okay. Just go all the way to the bottom.
Oh.
So not stay at the bottom. Okay. Because some of these are different. We don't want to look at the old ones. They're way harder to write. This cancel before sent to server one, this is written like the nice new way, and that's how you want to write it. So you can see
workflow function.
Make a workflow function here, and you make a little timer. It reads just like normal workflow code mostly. And then below that, you construct history by hand that you expect it to look like. And then you just like run everything. This is more or less what the test you'll write will look like. But
what am I asserting? I'm asserting command 0.
Well, this is because it was canceled before it was sent to server, so we never sent, any commands. Right. Yours will say 1, and it'll check that it was the right type of command.
Okay.
Yeah, but the other thing that you'll need to do to make this work is you'll need to add the Upsert search attributes like API to the like prototype REST SDK that you use to write workflow code. So, and that part will actually probably be more interesting to you than anything else because it's like closer to what like a user would care about.
So somewhere, basically like the prototype REST API, REST SDK.
Yeah.
Where is that located?
Yeah, let's go back to the top source, and this needs to be broken out into its own crate too, which is going to be a real bitch. But there's prototype REST SDK right in the middle there.
Oh my god! Is it one file?
No. There's the way you define modules in REST is you can name it, and then there's also a directory which has sub. So you might have seen if you were back at the top, there's a directory for it too.
Let me just take a quick.
Yeah.
Look.
See, there's
this one. Yeah.
Okay. So that has more stuff. So what you actually care about is I think mostly inside of that directory. So go to like workflow context, the file there. And this defines pretty much all the stuff the user interacts with. So like if you search for like timer, there's probably gonna be a lot of hits, but there'll be just a function called timer. There we go. So like you're gonna write one kind of like that, right? Except it doesn't even need to like have a return value because I don't think there's anything meaningful to return when you do this. I'm pretty sure. I'm not 100% sure about that. I don't know if like upserting a search attribute is like a thing that we like block on until it happens. If it is, then it will. I don't actually know.
My impression is no. It's like a signal.
Okay, in which case this just won't really return anything probably.
Yeah.
But like you'll do something sort of similar here where you like, you know, are acting like Lang and you're sending the thing that we talked about, the like local proto message that you have to define. That's like, hey, I want to upsert a search attribute, and like you'll send it to the core side, and all the right stuff will happen.
Cool.
Sweet.
Have you covered it?
Yeah, I mean, those are the big pieces. You know, it'll be fun to figure out the details. But yeah, like just feel free to Slack me whenever, and I'm happy to help you out.
No, I appreciate the time. You could probably do this in your sleep, but it's a chance for me to learn, and
yeah, totally.
That's always helpful.
I think it's a good idea for sure.
Okay, that's it. Thank you so much.
Cool. Sounds good. See you, Sean.
All right, see ya. So it turned out to be a bunch of files, man. It wasn't that. I thought it was going to be like 2 files. Then it became 4 files, and then I think it's like at 7 now. So this is just like uncommented out. Give it the right value. implement the message,
Right.
funky alias things. I really want to sync with you on like naming, because I really struggle with like what should I name these things. Like there's 3 or 4 different variations I could try to name stuff.
Yeah, I mean, at the end of the day, it's not that important. Like, I think it's
It's important
clear.
from like like code base sanity thing. Like,
Yeah, I just mean like, I don't know, like you're not gonna. I don't think that slight naming difference is going to confuse anyone, right? Like you come along, you see, oh, okay, I know it. It's a command and it's that one, so it's pretty clear what it is.
yeah. Okay. I have some messy imports here that I copied and pasted, and I'll clean up later. But right now, this is the main thing that I don't know about. I have to import Temporal SDK core protos, core SDK, workflow commands, and then I cannot get any of this right, no matter what I do. So I'm imagining something here is wrong. So I'll show you what that looks like. But then I implemented the rest, basically exactly like the timer. I went for a cancelable command, even though I was originally not planning to, because I saw like everything else, including signals, is cancelable. So I don't think that upsert search attributes is that special that it deserves different treatment.
No, yeah, that's probably right. I need to
So
go look at that. I,
so
I
so
think
this
what it
is
is it's just not. The name should maybe be more like maybe cancelable command. So I think that's fine. Yeah.
um that said, like I think that there's some more states to implement if it's cancelable. So I was very
It's not
hesitant
actually
of doing
cancelable.
this.
Yeah. Don't worry about that.
Oh, okay, all right. Then like, what is this? I don't know. I just copied it. Yeah, and then I added some enums.
Yeah, so that
So
part's probably a little. I mean, so the thing with Signal is it actually is cancelable. Like in the sense that you can decide to cancel it in the same workflow task before it gets sent. Um, I think I have to go double check that. But that wouldn't apply to this here. I mean, so like this, like the unblocker thing, it doesn't matter to you, right? Because that's resolving it with some value eventually. And in the signal
Mhm.
that happens because that happens when it like is confirmed as received. But that never happens here.
Yeah, yeah.
I don't actually know that there's anything that existed in the like prototype SDK yet that was like completely fire and forget like that. So it might actually make sense to give it like a slightly different treatment, but I can come back and look at that later.
Yeah, I mean, I saw some fire and forget stuff in here. Because I really spent some time looking at like what all we do. Anyway, I think you can unblock me really quickly
Okay.
with there's just a very simple message, which is me running cargo build, and then running into this error. So like I have no idea where this import comes from, because I tried everything. So this is the one right here, where I tried to. This is in workflow context.r. Actually, no, sorry. Let me start with this one, because this is like the really basic one. So this is inside the state machine file.
Yeah.
And I need the type to come in from the proto, and I cannot get it to work. And I don't know where the source is from. I don't know.
Well, so go back to the proto where you like uncommented the line.
Okay. This one, local workflow commands proto. Okay.
Yeah.
All right. So this is called upsert workflow search attributes.
Yeah.
And over here, I called it upsert workflow search attributes, the same exact name.
You probably didn't trigger the protos to actually recompile. Like the build
Right.
script doesn't know anything about like it's not, it doesn't have a way for me to tell it that it should recompile when these files change. So just go, like there's a file called build.rs in the protos the protos like crate. If you just search for any, there's only one of them. Yeah, that one. Just like add a line here. Just like add a line and then hit cargo build.
Oh. That's okay. cache busting, right?
Yeah.
These errors look different.
Yeah. So it hadn't compiled it yet, I don't think. I think you actually just scrolled back to your previous error there.
Past it. Yeah. Good. We have new errors. Okay. I can work with this. So is the recommendation that I just keep bumping things like that?
Well, if you need to change the proto file again, which I don't think you really need to.
Right.
There might be some way that I can instrument it to notice that it needs to recompile when these get changed, but it wasn't obvious that there was an easy way to do that.
So how about if I add a comment like this? If you change the
but it's not, you need to put one in every single proto file. So if it
knowledge.
if it goes anywhere, it could just go in like a readme or something. But
right. Yeah. Okay. I mean, I have a bit more yak shaving to do here. I don't know what this.
Well, that's fine. You just need to. You need to implement the display trait for that now, and that's done inside the like proto's lib file where there's all sorts of boilerplatey stuff having to do with the proto.
Which I did. I didn't see any.
Well, because I mean, this is even though things are spread out in a few places, right? I mean, this is kind of the advantage of all this type system stuff is you kind of just, when you add one of these things, you just do what the compiler says until it stops complaining. And then you've kind of got everything you need, right?
I got you.
Yeah.
I didn't see what lib file. Let's see.
The proto crate lib file. It's like the main one. You might not have touched it yet.
I don't think
because you didn't get to this point because you never actually had the code for this message generated. So it never would have mattered until now. So in the same, in the source there under SDK core protos. Yeah, that.
I remember looking at this. We discussed it, but then we didn't do anything about it. Okay.
Yeah. So here you'll find there's some like impl display. It'll be for a bunch of different things, but in the same section that includes the generated workflow commands code, there'll be some display implementations for the different commands.
These are commands?
No, there's this is like every.
Yep.
There we go. That's the one. That's the area you're looking for. So you'll just put one in there for Upsert workflow search attributes.
All right, I can do that. Okay. Let's see if I have any other errors before I let you go. And then, that's it. Okay.
Well, that can't possibly be it because what you just copy pasted won't work. But
well, I mean, I didn't run it. Yeah, I was just saying like if I.
Yeah.
Okay. Maybe what I can do is I'll highlight as I fix this. I'll highlight any other questions that I had running through this. I call this indexed fields. I don't know if it matters what I name it. Or I took it straight from the proto again.
Yeah, that's a shitty name, I think. So I mean, we can just. Like it. I mean, it sort of makes sense. I guess I understand what it's going for because it's like they're like indexed in the Elasticsearch sense or whatever. But we should just put that in the comment, right? That's the main problem with all the upstream protos. That although I did finally merge that PR where I gave more meaningful comments to a bunch of them, but like they just don't have anything in there. So like these proto definitions, I think in general, I actually have like pretty meaningful comments for most of the fields. So it's good to, if we can keep doing that. I also don't totally know that you even need a sequence number.
Yeah,
but we can come back to that later. Like I wouldn't worry about it right now.
Okay. So all right. So you're okay with me renaming this to something?
Yeah, I think just like attributes is I don't know.
Well, I originally had like search attributes like that, but I don't know if it's too repetitive.
Yeah, I'm also not even totally clear on what the. Oh, right, because the payload is just like the value for whatever the
key value. Yep.
Yeah. Okay. Yeah, you'd probably want to, yeah, in the command or whatever. But yeah, I mean, I think that roughly makes sense. We should also add like what it actually means, right? Like, the keys, some search index, the values, some search value. That way it's at least a little more clear.
Key equals search index, value equals to value.
Okay, yeah, cool. That makes sense to me.
All right. This is fine. This is fine. These imports are messy. This is fine. Yeah, okay. This shared state thing. I actually wanted to try to inline all this because I didn't know if I needed.
Yeah, you don't need shared state, right? Because like all you're doing with the attributes is just immediately
Relaying
consuming them and pushing them into the command. So like
Right.
you can forget them after that. There's no reason to keep them in memory. So
Okay. So I'll just remove this. Okay, let me just kind of mock it out because this will be really fast. Okay, it's right here. Good state. Okay, so what we're saying is this goes. So what I actually wanted to do, but I chickened out, was I don't want to do any of this. I just want to take.
you mean inline that all into the top level function?
Yeah,
Yeah, that's totally fine.
that's my instinct is if I don't need it, then
Yeah, no, that's totally like I mentioned yesterday when we were talking about this. There's some sort of pointless
direction
going on, yeah, in some of these.
Okay, all right. Good. I mean, I just wanted to. So now I know that shared state is for keeping it around. And does that correspond to mutable state? Is that a different?
No, not a totally. Yeah, nothing
Okay.
to do with it.
It's a server-side only concept.
Yeah. Now, importantly, you don't need to clone attributes anymore, which is sort of a nice thing because you won't pass it into new. In fact, you won't even have that new line, right? You'll be making it the manual way you did before.
I may have. Okay, wait, hang on.
Yeah, so like the first line there, now it needs to just be equals. Like you're going to create the struct because you just deleted that method, right?
What are you talking about? What one method?
You just deleted the new method. There is no self new now, and in fact, there is no self even, and you can't even access self here. Yeah.
Oh God. Okay. All right. Screw this. And then, is it really that simple?
No, because you still need to construct the actual state machine struct, which is what that should be. But it's not even really going to have anything in it. It can't be a tribs. It's whatever. It's the name of the state machine, which is at the top of the macro.
Yeah.
Yeah, exactly.
Sorry, give me 1 second.
There we go. Except it's going to need curly braces after it. And you're still going to need to pass some fields, but the compiler will tell you what those are if you just try and run it.
It's probably just one.
It's going to whine. It's going to be like, I don't know what shared state is because that's probably still up in the macro.
No,
I don't know why it's saying that because we just added that a little bit ago.
That's fine.
Yeah, it's definitely not fine. I guarantee that doesn't work. Yeah, it's because it's dying too early on the other
on the other thing.
This display thing, which I'm not totally sure why it is because it seems like you just added that. I don't know. Is it not saved or something? Do you not have autosave?
I didn't save it because I haven't looked at the implementation yet. So implement display for formatter. Oh, it's just like how you report the bugs. Yeah. Okay.
Well, it's how they show up. It's not. It's and that won't work because that field doesn't exist. Because it was from the other thing you copy pasted. Yeah, see that you have to get rid of that guy. So just get rid of that whole thing. Get rid of the curly braces inside because now it's going to complain because you have an unfulfilled. Yeah, there we go.
Strings.
Yeah, you probably are actually.
Oh, right. Yeah.
Yeah, you can get rid of the parens because they don't really serve any purpose there. You might want to actually end up putting the search attributes in there, maybe, but like don't bother.
It's up to 100 of them. Yeah.
Well, and I'll come back and do this later. What I need to do for all these display things is like when you try and display format a payload, I'll truncate it so that it only takes up a few characters instead of blitting the whole thing to the screen, which is pointless.
Right. Exactly. You just want a little hint of it.
Yeah.
I mean, there's up to 100 of these, so there's too much for one screen.
Yeah, there's all sorts of little like bits of truncation display stuff I want to do. So
the language server for do you use VS Code? The language server is
no, I use CLion for exactly that reason.
Yeah. Okay. Okay. All right.
Yeah. So this is what I was saying. So like now you need to go to the macro and like, since you don't actually have any shared state, replace the shared state type with just like the unit type. So just put like parentheses there, just empty parentheses. Yeah, like that. And then when you construct it, you're still going to need to provide like the shared state field, but it's just going to be this like bit of empty shared state.
But why is this trying to find? Okay, yeah, all right. When I construct it, sorry, let me catch up. I'm not using it anymore.
Well,
as far as I know,
the field still exists, is what I'm saying. Like the macro is still going to the way it defines the state machine struct still has this shared state field. It just is 0 size now. It takes up no space and doesn't do anything.
Is there watch mode, by the way? Is it just like a W flag?
Yeah, you can do cargo watch if you want.
All right. Looks like a bit more yak shaving here. Do you think I can handle all this?
Yeah, probably. I mean, this is all like stuff the compiler is going to tell you how to do, pretty much.
All right. Well, I mean, as long as you're happy with where I'm going.
Yeah. No, I mean, this all makes sense.
It's good. Cool. Well, I'm having fun.
Good.
All right. Well, I'll check back with you when I have questions.
Sounds good. All right. See you later, Sean.
All right. Thanks, Spencer.
Bye.
So the first thing, what you see here is the upsert attributes state machine being registered, first the machine kind being registered into an enumeration here, and then the state machine itself being registered into an enumeration here. This is so that sort of the higher level machinery has enumerated handles into the type and the kind of the machine. This file, okay, so I'll bundle that up. This file here is really just related to pretty printing some coverage analysis for visualization of the state machines. So it's not a big deal, but this just results in the visualization of the state machine. The edges turn green if they are hit during a unit test.
Gotcha. Yeah, I never came across this file, but I guess I wouldn't run into it until much later.
I didn't come across this file until I opened the PR, and the so if this is missing here, this string here, this is a branch of a much larger match.
Huh.
So this string being missing led me into this panic here, and so the unit tests didn't pass.
Yeah.
That's how I found out about it.
Yeah.
Okay, this here, fold that up.
Yeah, this is the core of it.
This here is the core of it, exactly. So imports got screwed up with. That's because I imported a bunch of things. The state machine I did change, and talked a couple of times with Spencer about this. You may have spoken about this before, but the core of this thing is that there's very little state to be managed for the state machine. Really, we're just issuing the command, and we do get an event back in the history saying that the command has been accepted from the server, but that's disconnected from the server actually applying the attribute update. So it's not super useful. but we can use that as an edge, as a transition in the state machine, right? So here we transition from created into the command having been issued. Issued, I sort of differentiate from created. Created feels to me just more like instantiated, I guess. And then from the issued, so at this point, the command for the purposes of this state machine, the command going up to the server has been sent. It happens to be that there's some higher level machinery that's holding on to it and hasn't flushed it out to the server yet, but it has, for the purposes of this state machine, been sent, so it's been issued. And then when we come back around and get a command recorded event, which comes out of history, a history update later on, then we transition into done. This command recorded doesn't even carry data. It's just sort of says the command was recorded by the server. Let's see.
I think so. Part of what I struggled with was not having visibility into what the macro actually generated. Where did I look that up?
So what I looked at the most.
Do you guys want to see some cool magic?
Yeah.
Yeah, actually, do you want to show it, Spencer?
Yeah, let me get it ready though for a sec. Finish whatever you're saying, because it's like a little bit of an incantation that I have to prepare.
Matt, if you're switching to ID, you probably have to switch the Zoom window too.
Yeah, I'm on a 34-inch monitor. That's why I'm not sharing the whole screen. But I'll just mention this. This was
okay. Sorry. Yeah, don't let me interrupt you.
This was sort of something that I had to learn. You basically had this. You had it in a slightly different place, but it's the same thing. And now that I notice, this doesn't actually have to be mutable. But when we first come to understand that we need a state machine, you have to instantiate that state machine, and also, and it instantiates into some like just born state. For this one, it's created, right? The state sort of hasn't done anything. Yep. And so we instantiate the state machine and also pair with it into this new machine with command type the first command that we want to feed into the state machine. And so that is how this edge here from created into command scheduled basically happens.
Okay.
Is the command that we put in here, this new machine with command, the command that we put in here, which you can see is a upsert workflow search attributes with the attributes that were passed in to begin with, which is a series of wrappers around basically a hash map. So that gets scheduled to get sent up to the server. It also gets round tripped back into this same state machine immediately and triggers the traversal of this edge. So once this upsert search adders is returned, the machinery schedules that command to run on the server and also sends an event back down into the state machine, which we map to this command scheduled event. And that's sort of how we bootstrap a state machine into a useful state.
Cool.
Okay, so I just sent you a thing. If you go into the core subdirectory, I don't think you can run it from the top because it won't work right. And then you run the command I sent you, it'll show you the fully expanded macro. So you can actually see everything that gets generated, which is pretty neat.
Oh, that was real what I wanted.
I mean, it's hard to read because it's like there's like a very verbose output, but.
So do you guys have a terminal now?
Yeah. Mm-hmm.
Yeah.
All right, let me run what Spencer just gave me.
I think you need to go into the core subdirectory first, though, before you do it.
Whoa.
And then it's probably going to recompile your entire project, unfortunately.
Cargo expand.
Oh, I also, you probably don't have cargo expand. So this might take a little while to do. Yeah.
I don't know if
Yeah,
there's-
no such command. Okay.
You'd have to install it first.
Is that cargo install?
Yeah, you
expand?
can just say cargo install cargo dash expand. But this might take a little bit.
Oh
It's a
yeah.
fun side project. Oh geez. Okay.
Yeah, we might want to come back to this one while this compiles.
Yeah, we'll come back. Sorry for the discussion.
No, I mean it's cool, and for like a video about this, it's kind of it's a neat thing to know about. So
I think all macros need something like this to demystify it.
yeah, and actually
guess-
from IntelliJ, they have a little thing where you can say like expand this macro, and
Of course they
it'll
do.
do this thing for you.
Does that work for you? It doesn't work for me.
It sometimes you gotta like punch a few buttons, but yeah, it does work. I have it in my terminal right now.
Okay.
All right. So then you went to shared state. Unused must exist. Yeah, this is something that I tried to get rid of because we
so-
weren't using it.
In the declaration, like I tried removing this, but it needs it to be there. So I just gave it
Oh, there you go.
a type that we're just never going to look at. But if there was state that we didn't want to copy between the various state types as we transition between them, then shared state would be a good place to stash that. Yeah, so Spencer just gave me some feedback on this, which is quite correct. This is too general, but this tripped me up here for a little while because this is, and the hint here is that is in the word machine, right? So this is a command for the state machine. It is not the same as a command that we send up to temporal server. And in the in the parlance of this state machine library, a command is really an output or a response. Sometimes it's referred to as a response, state machine response. So if you think about, you have a source state, and then you follow some edge due to an event, and then you have a target state. And we go through that transition. When we go through that transition, there can be outcomes or like side effects of that transition. And so those are what we're looking for here. And so in particular, this send upsert command is the side effect of transitioning from that created state into the, well, it's actually not. It's only used because this is the command that we send at the outset when we first create the state machine, because we already know that we need to send the command. Otherwise, we wouldn't have created the state machine in the first place. But if there were other, if this was a more complex state machine with 3 and 4 different states and some branches and stuff like that, you might have different state machine commands or state machine side effects that you would want reflected in this enumeration here.
Yeah, it could be called like output alphabet or something if you wanted to be super technical,
Right,
but that would be a
vocabulary
mouthful.
or,
Yeah.
Effect set or something like that. Yeah.
Cool.
Now,
I really love the comments that you're putting in here, by the way. Makes it much clearer.
oh, okay, thanks. I used the wrong commenting. This has been fixed up actually to be to have triple slashes, but so created, command issued, created and command issued are, if we go back, you'll see here created, command issued, and done should be around here somewhere. Created, command issued, and done. Yeah. So there's no state to any of these, but each of them maps back to a state. Yeah, there's no state to any of these. These types are states in the state machine. The types reflecting the state in the state machine do not themselves have state, but we could easily put, names or various bits of state in here and transition it between the states, or we could use the shared state object to stash things if we wanted to. But none of that was necessary, so we just have some empty structs here.
Nice.
New is a very simple constructor for the state machine. its initial state is created, and shared state has to be set. I guess I could have used default here, but shared state is just set to the empty tuple. And okay, I have updated this, so I'm going to refresh. This state function I'm not going to explain because I actually was able to remove it. Oh, this is the commit. The commit's going to be the same. Oh, it's going to be there. So I clicked on the wrong one. Sorry.
Yeah, it's all right. We can skip whatever you were removing anyway.
Yeah, so Spencer pointed out that I needed in the unit test a way to inspect the state of the state machine, right? Because one of the things I did in the unit test is instantiate the state machine and pump some events into it and then assert that it end up in the state that I expected it to end up in. And so I just needed a way to access the state. As it turns out, there already is a state function on the generated state machine. And so I didn't need this. And I was probably just masking it by implementing that. Okay, the adapter sends you for a little bit of a loop, or sent me for a little bit of a loop. There are two things that get fed, or no. There is a native vocabulary of the state machine, right? And the native vocabulary of the state machine are the types that get generated by the code generator out of that macro. But there's really no way for the more abstract, higher level state machine management code, right, that has a hold of a state machine and knows that it can push events into it, but it doesn't know those specific event types because they're generated on the.
Oh no.
Fly.
Did he drop out?
Yeah.
Oh,
Matt, you dropped out, for your connection dropped for a bit.
Sorry.
Rewind about a couple seconds.
There's sort of two layers at play here, right? So there's a top level layer that knows how to feed various bits of data into a state machine, but that has to happen in a generic way because that top level state machine doesn't know the specific vocabulary of that actual state machine implementation. It doesn't know the code that gets generated out of it. And so it has to push some sort of generic structs that have like a type annotation and a variant in them or something like that, right? The state machine, the core of the state machine itself that's doing the transitions, it natively speaks that state machine language that we just defined up above. It knows those events and it knows those types. And so we need a shim or an adapter layer that can take the more generic form of commands and events and things like that and transform those into the native state machine, lower level state machine language. And that's what we're looking at here. I'll start with the bottom here. So kind is for state machine kind. So that just means that this, it sort of lets this state machine be kept in a registry by its kind. Matches events just says that this state machine understands and takes exactly one kind of event. Well, this implementation says it takes one kind of event, which is the upsert workflow search attributes event. And then this is probably the most interesting one, which is transforming from the machine-specific command into the more generic command needed by the abstract state machine, the higher level state machine, right? And so when we issue the machine-specific command of send upsert command, which we defined just above, right? That is this send upsert command here. When we issue that machine-specific command, we need to adapt that to some sort of type that the higher level state machine manipulation language or state machine manipulation library can understand. And so we match on that, pull out the attributes there, and instead instantiate this machine response issue new command. This is what says to sort of the higher level layers, I want you to issue a command up to the server. Now, when I say command, I'm not talking about state machine commands. I'm talking about API level temporal commands. And in particular, obviously, with this being the state machine, this is the temporal command to upsert search adders. And so the command that we send is going to have this upsert workflow search adders, and the attributes are going to be just a copy of the adders that were initially in the native language and the native enumeration. So this is just a type adapter taking a state machine specific, something that is known really only in this one file, a state machine specific view of it, and changing it into the protocol that the temporal server uses, the command protocol.
Yeah, it's a super good description. And for some context for anyone who ends up watching this, like, this is like kind of not important really anymore, because the part Matt said earlier where like the top level, like the higher level stuff that holds on to all those state machines only understands them generically, like strictly speaking, isn't true anymore. Like I changed that at one point because I needed to do some things for local activities, because local activities are super weird. And it got to the point where trying to interact with them generically was sort of intractable. So now at this point, the higher level stuff actually can, like, if it knows that a machine can be a certain type, it can like reify it to that specific type. And then this whole layer could go away if we felt like it was worth making it go away, because instead of kind of passing them back into the machine and having it do this adapting thing, I can just say, okay, well, I know this state machine is this type, and you could kind of do this transformation like directly instead of having this extra layer. But it didn't used to be that way, which is the reason this still exists, and it's not a big deal to get rid of.
So obviously the code here is pretty trivial. I think from a cognitive load perspective, I think it would be great to get rid of this, because
yeah,
when I came onto this, it took me a while to understand it.
Yeah, I agree with that. It's definitely a little loopy for sure.
So cancelable, I'm just taking the default implementation, which panics if somebody tries to cancel it. This needs to be here for compilation reasons. Okay, so when the higher level code wants to inject things like a history event or something like that into the state machine, it needs a way to, again, convert that history event into a state machine specific event, like command recorded here. And so this implements try from, which maps a history event into a state machine event type. If the history event on offer here is an upsert workflow search attributes, then we say, okay, that is a command recorded event in the in the alphabet of this state machine. Anything else you try to feed into me is going to be an error. But this should be anything that hits this try from should first, I believe, go through this matches event function, which only accepts this matches event predicate, maybe I should say, which only affects the upsert workflow search attributes. And so that's what prevents non-matching history event types from being fed into this try from here.
Yeah, really, we're just like appeasing the compiler here. Like in some sense, we already know that it can really only be that one thing. Like we already checked that before.
Never reach this. Yeah,
in theory, we could put the unreachable macro here in the catch-all path, but it's fine to be a little more clear here.
And by the same token, this is a similar thing, except for commands. And this maps command types into machine events. And the same way, upsert workflow search attributes command here is mapped into the command scheduled event. So Spencer, I noticed you commented that these should not be necessary. It doesn't compile as it stands without them, but that could be because I didn't implement maybe default someplace else.
I think you did, though. I think you derived it for them. I'm not totally sure. I would have to go double check something.
Okay.
there is some logic somewhere where it says, okay, if the states implement default and the transition doesn't have any handler and your transitions don't have handlers,
Yep.
then it'll just use the default
default
conversion. But
Yep.
I probably missed something there.
Okay. So all these two from, so you can read it as, this is the transition from the command issued state into the done state. This is the transition from the created into the command issued state. I should probably reorder these so it makes a little bit more sense. But the state machine framework allows for there to write arbitrary handlers for this, and the handlers can return those state machine side effects that we talked about earlier. But because we have no need for that in this case, all we need to do is, given the starting state, we need an instance of the end state, and that's what this from allows us to happen here. And if we didn't want or need any side effects, but there was some pieces of state that we wanted to transition between the two, like if command issued had a counter in it, and we wanted to copy that into done, that this is the place where we would do that. There's just no need for that here. And okay, so everything else we get into tests. Testing. So the first thing I want to point out in testing here. So there's two main tests that I wrote. This is upserting search attributes from a workflow. So we're going to sort of instantiate a workflow function and run it to completion. And that workflow function will include running upserting search attributes. And we can assert that those commands ended up in the place that we expected them to. And then the second test here is this just directly manipulates the state machine. So maybe I'll start with the simpler one. Create the state machine, assert that it came up in the created state, create, this is just, I'm going to use these later, but create a command scheduled and a recorded history event so that I can use them later. And I do this through the adapters that we saw before, the froms that we saw before with try into, just to exercise that code. And then here, this on event wrap or on event mute is how basically wraps up how to inject an event into the state machine. So here, the state machine is already in the created state. Now we're going to inject the command scheduled state machine event, and then assert that it's in the command issued state. And then we're going to inject the command recorded event and assert that it's in the done state. So this is basically direct manipulation of the internal state machine state. This one's a little more complex. Here, we first create a fake history. We're going to create a fake history on the fly. Use this test history builder utility to do it. We're going to add, the events are going to be workflow execution started. It's going to be a full workflow task run, and then it's going to complete. And so we're going to create a workflow function here, which is going to match up to this history. And in particular, so a workflow function, there is a not fully complete, but pretty close to fully complete, as I understand it, SDK implementation in Rust as part of the core SDK, because otherwise, how do you test anything? You need a Rust SDK. And so this workflow function here and this workflow context are pieces of that. Workflow context, you hang a lot of things that we hang off of our context objects in general in the other languages, right? So Upsert search attributes was one of the functions that I had to go and implement on workflow context. That must be down below here. And what I'm doing here is inserting a search attribute. The attribute name is foo, and the payload here is just blank. There's a subsequent.
Oh shit! I just realized I'm late for an interview.
Oh,
see you guys.
Okay. Yep.
Oh, go. Yeah. Well, I can share.
Okay. So this creates an upsert search attributes the workflow function is going to run. It's going to run the state machines. It's going to find, run our state machine. When we call, okay, manage workflow func. So we wrap this into a manage workflow func. And the manage workflow func, when you call get next activation and wait on that and unwrap it to make sure there was no error. And we're going to pull the commands out of that manage workflow func now, because it ran this whole function here and returned okay. The commands should include the upserts workflow search attributes command. So assert that it's not empty and assert that sub-0, the command type of the first one, is in fact an upsert workflow search attributes command. And that passes, and then you need to shut it down so it does some cleanup after that. There's a better version of this, which I might be able to show you. Yeah, more assertions. So here, this is the same workflow function, except I'm inserting 2 search attributes now, or upserting 2 search attributes, foo and bar, key 1 and key 2, K1, K2. K1, the data is 0x01, K2, 0x02, right? So that's the data that we're upserting. And then when we come down here, match against the actual command that we pulled out, and there's sort of a series of optional types that we need to pull things out of, but you end up with payload 1 and payload 2, and we assert that the data is 0x01 and 0x02 respectively. And then if any of this doesn't match, just panic out of there. And that basically, those are the changes. I think a little bit of the most of the confusing part of this, it might have been easier overall to do with actually a more complex state machine where there were, because then it would have been more clear what the purpose of some of the machinery is. But a lot of what's here, like, the number of functions that were just like, this is just here to satisfy the compiler because we don't need that flexibility for this particular case. And so you get that nag in the back of your head, like, well, it's there for a reason. Maybe I should implement something in here, right? So.
Yeah, definitely felt like that. It also wasn't clear. I mean, just the thing that really gave me no confidence was the opaqueness of the macros. I've been trained to dislike macros for that reason, but I think obviously with sufficient tooling, then that is not a problem.
Yeah, there's definitely some stuff that I ran into that was a little immature, I thought, from the Rust perspective. And yeah, I mean, you heard Spencer talk before about, like, the reason that closure needed move, async move, was because async just isn't completely integrated into the language yet, things like that.
Yeah. Okay. Any other just like tips in general for just insights about the Rust code base that you've had so far?
I'd say I'm an avowed Vim user, but I would say if you're new to Rust, get CLine. We have a company license for it. Get CLine with the Rust plugin, and let it point out the really basic low-level stuff. That'll make your life easier. And other than that, no, it's okay. I forgot that Rust tends to put unit tests in the same file, and just put them behind if the configuration, if you're in a test configuration, then it'll compile them. Otherwise, it won't. So I was looking around for a lot of tests and didn't find them, and then remembered.
I kind of like that because you co-locate. When you move things around, it's right there, and you search and replace. You find whatever you're trying to change. So
I like it as long as you undertake the discipline not to use similar code in your actual code, like similar, if the config is test, then your actual code works one way, otherwise it doesn't. Because if you get too much of that into your actual code, then you're not testing the code that runs at runtime, which is always a dangerous situation.
Gotcha. Okay, yeah, and I think Spencer also mentioned that we might want to do one more integration test or something.
Right. Yeah,
So
I'll follow up with him on that.
That'll probably happen. No, but thank you for taking the time to tour through it with me. I probably would have taken 10 times more time than you did to figure all this out. But I think it's valuable, and I wanted to make more content like this where it's just us kind of working through it. It's all open source anyway, right? Like there's nothing secret about this. So let's open it up to people. That's all.
Okay. Cool. All right.
All right.